Hey team, this is Mrs. Hunter. Let's go ahead and take a look at the answers to these practice problems. So all of these are neutralization reactions. You'll notice I have an acid mixing with a base. So the first thing you know that you will always get is water, right? Because that's the hydrogen and hydroxide from the acid and the base respectively. And then what's left? So we have cesium, and I know to put cesium first because it's a cation. It's got a positive charge, right? When we look at the periodic table, it's in the first column, so right, +1. And nitrate is the anion, so they always go at the end, and that's just convention. And nitrate has a charge of -1, and you know that because you memorized it. So +1, -1 means we don't have to change anything. So now if we go to balance, everything is already balanced because we don't have more than one of anything. Or we have one of everything, I should say. All right, let's take a look at example 2. So we have hydrobromic acid and calcium hydroxide. All right, so again, the acid and the base, the hydrogen and the hydroxide are going to make water. You do not need to worry about that. We will deal with that little 2 that when we go to balance later, okay? So you make water, and then the stuff that's left over, you have a calcium and a bromide. Well, the positive one, the cation, is the calcium. That's going to, by convention, be listed first. And try and remember to leave yourself space to balance. So calcium is in the second column. It has a charge of +2. Bromine, right? It's a halogen. It's next to the noble gases in column 17. It's got a charge of -1. So, we need 2 bromines for every 1 calcium, right? Because this is +2, the bromine's -1. So in order for these to balance. Okay. And now we do need to balance this equation. So let's go through it systematically. So there's 1 hydrogen, 1 bromine. On the product side, there's 2. So I'm going to put a coefficient of 2 in front of the HBr. Now, yes, that does give me 2 bromines, but also 2 hydrogens. So we're going to put a 2 in front of the water. That will give me 2 hydrogens, but also 2 hydroxides. If you look over here, there are 2 hydroxides, so that works out. And then 1 calcium, 1 calcium. So if you want to double check, this should all be balanced 2, 1, 2, 1. All right, let's take a look at that last example. We have sulfuric acid, potassium hydroxide. Again, strong acid, strong base. They're going to completely neutralize each other. So every neutralization reaction, you get water and some kind of salt. So I know I can write HOH. And yep, you see the 2 there. Don't worry about it. We're going to balance it when we balance the equation, so don't worry about that. Now, we have sulfate and potassium ions. They are going to make a new compound. The cation, the positive one's always written first. So you look at your periodic table, you're like, oh, right, potassium, alkalides, +1. And sulfate is a polyatomic ion that you've memorized is -2, or you have your sheet out in front of you. So if potassium's +1 and sulfate's -2, you're going to need 2 of those positive +1 potassiums to balance out that 1 sulfate, because that sulfate has a charge of -2, right? It wants 2 electrons. So we're going to put a 2, so it'll be K2SO4 as the formula. And then you no longer need those little charges there. So this is pretty much ready to balance now. So there are 2 hydrogens on the reactant side, but only 1 on the product side. So I'm going to multiply the water by 2, which is going to give me 2 hydrogens, but also 2 of that hydroxide group. So on the reactant side, I only have 1, so I'm going to multiply potassium hydroxide by 2. So it gives me 2 hydroxides. Now that also gives me 2 potassiums. But if we look on our product side, we have 2 potassiums. All right, let's keep checking. So hydrogen, 2, 2, sulfate, 1, right? Because you can keep that group together. So sulfate's 1, and then there's 2 potassiums, 2 potassiums, 2 hydroxides, 2 hydroxides. So hopefully you are a neutralization reaction champ, because we're going to use them to talk about titrations next lecture.